Static check basically say, okay, I run a set of tool over this, and it will pick up things that more likely to be a problem, then human can look at it. Okay, it's not a replacement of human. Static tool is not a replacement of human. Static tool has a very high false rate, which is when it raises alarm, it may not be alarm. Okay, so you have to still eyeball the code. This is basically execution-based testing and non-execution-based testing. Basically, in our testing terminology, would be inspection and testing. Inspection really just looking through the code or code review. Okay, code review and the inspection, this non-execution-based testing, is surprisingly as effective as execution-based testing. That may be counterintuitive, right? If I run my code, it works, it works. If it doesn't work, it doesn't work. Why is looking at the code has equal chance of finding problems? Actually, when you run the code, sometimes it's easy to see it's correct. But when it's wrong, it's really hard to see why it's wrong, right? But in terms of review, it's actually, when you read the code line by line, you can actually find problem. So that's why code review is another skill all industry group will force you upon. That's why whiteboarding is the way to go. Okay? So they basically, that's a way for them to basically go through, let you write the code and you are actually review your code as you go. Okay? Very effective way for you to show that you're capable of doing that. Modularity, we just talked about it. Modularity, modularity, modularity. If you don't have modularity, you cannot scale to bigger programs, you cannot work in a team, you cannot reuse your code, and all the good things cannot happen. So keep in mind, never break your modularity. Okay? Always keep your modularity. That's the base of scaling up to bigger and bigger programs. How do we scale up from being able to code 100, 200 line of code to 2,000 line of code to 20,000 line of code? The only way to go is modularity. Okay? Define sound interface, reuse our code through module, the only way to go. Okay? There are no magic formula here, but to go with modularity and reuse, you can scale up. So what is software project management plan? Basically, it's divide and conquer plan. How you break a big thing into small pieces to the point that I can hand it over to you. This is going to be implemented in 50, 200 line of code, and then I hand this over to you. And this is the level you, as a single programmer, should be able to comfortably handle within a day or two. Okay? So software management plan is essentially for you guys as a team or software architect to actually break the work down into work items. Right? So this is very clear in terms of fast food restaurant. Okay? I think you guys all have probably been to a pizza ready to make place, so a similar place. Essentially, I mean, just to say, so nobody can make a hamburger just by one action. There's no way. Okay? If I tell you that, you will say you're lying, you're crazy. Nobody can say, okay, I'm just going to make one action, a hamburger is ready, you can go eat it. No, that doesn't happen. You know that when you go work for McDonald's, they will train you for steps you need to take to make that hamburger. They actually have very clear breakdown work. Okay? Every step you need to do to get that job done. So that essentially is divide and conquer. Then they will have a pipeline. You don't necessarily make every part of the hamburger. They actually flow through a pipeline, and each person only responsible for one thing. Right? For instance, somebody at the end of the counter actually basically wrapping the hamburger, put it in the box, and in the middle somebody is making the bun, and somebody prepared it in the patty and everything. So essentially, it's a breakdown process, but the end product, the thing to achieve, is actually a hamburger. Okay? So software engineering plan is the same deal. How we break down a big piece of work or product into manageable pieces so I can hand this over to each one of you. So you can work on this for a limited amount of time, 1 day, 2 days, sometimes a week or 2 weeks. I don't recommend anything go beyond 2 weeks. If you have some job, have somebody out there do it without talking to you for 2 weeks, the chance they go astray is as high as 100%. Okay? They are going to get it wrong. You know that, right? So you have to cut it into, unless you really have a team that work together very well, then I've been working with him for a long time. I know exactly he will be able to finish 2 weeks worth of material. I can give that to him, and he will come back with all the right results. If you have that kind of confidence, then your team can scale bigger. If you don't, okay, you give him 1 day worth of work. So if he make a mistake, only 1 day lost. That is also the core of so-called incremental development, agile processes at the core. Okay? Don't let people make too much mistake. Give them a small amount of work. Let them finish. If they made it wrong, lost 2 hours, lost a day, not a big deal. But if you lost 2 weeks, it's huge. So we already break down how much you guys cost each hour, right? 75 to 100 bucks, right? So for instance, if you got hired by Intel as a contractor, you're probably getting $70 an hour, okay? $70 an hour, if you let this guy work a day without coming with any result, that will be 500 bucks right into the tube, right? So that cannot happen. 2 days, that will be $1,000, and a week, it's going to be a lot of money. So that's not the way to go. So-called agile process, incremental development, the core is actually give them manageable pieces to do, so they won't make big mistakes, and you can adjust the plan as you go. Okay? So that is the dominating process we use in software engineering today, right? So you don't let people go work for a long time without coming back to you. You give them a small chunk of work to finish, then come back and give them another chunk. Okay? Incremental development and agile processes. All right, we'll talk about those things later. However, no matter what kind of process you run, for instance, just like the incremental process we just discussed, for anybody to do the job, they still need to do 5 things: requirement, analysis, design, implementation, and testing. Okay? Just that, do you allow them to do that within a week? Do you allow them to do within a day? Do you allow them to do that within 2 hours? Or do you allow them to do that on our board for 30 minutes? Our quiz is a small task for you to finish, right? Guess what? You still need to do the 5 things. Requirement. Hopefully my sentence is clear enough. You don't have to spend way too much time on that to figure out what I'm asking, right? Then you need to come up with your design. At least you have to come up with a class definition. That's a design. Then you need to code. And actually, at the beginning of the class, I'm asking you to actually test your code and get it delivered within 20 minutes or 30 minutes. Okay? So that is why company wants you to do online test or do it on your laptop and do it on the whiteboard, because that is essentially asking you to execute a whole software engineering project within 20 minutes, 30 minutes, and 40 minutes time frame. Okay? So that's basically, if that adds up, You can work every hour on that pace. Then you can see how productive you will be within a day. So let's ask this question. How much code you code for that class last time? Just a rough ballpark. How many lines of code? 40? Is that a rough number? Okay. 40 lines of code. How confident are you that sure about whether it's correct or not? Okay? That should be our expectation. Okay? Within 20 minutes, you can write a code as difficult as this. In about 40, 30 lines of code, and then say, I write it down, I write the class definition down, I write the code down, I test it out, and it should work. Okay? So let's reduce that to 25 lines. Okay? Then that's my first test. Say I'm a hiring manager at Amazon. Okay. I test within a day. It did 5 challenges in 5 hours. Actually generated 125 lines of quality code. Actually, great hire. Okay? If you think about it, if he can generate 125 lines of code in a day, in a quality day, if you have him work in a week, that's basically you are looking at 500 lines of code, quality code. That's a lot. Okay? That's a lot. That's more than a software engineer generates in a week. Okay? So pretty much, then you will say, okay, that 500 lines of code are not going to be all production code. Actually, so I would say probably 1/4 of that code will really go into production, and the other 3/4 will actually be testing code. So you're essentially looking at this software engineer generate 100 lines of code for production. Okay, in a week. All right. So how many weeks we have in a year? 52. Give you 2 weeks off, right? You still have 50 weeks, right? So wow, this guy can contribute 5,000 lines of quality code product. That is more than an average Microsoft Amazon engineer contribute to the repository each year. This is how software engineering actually scaled. Okay? That's why they want you to write code. Because if you can finish this comfortably within the time given, then they have a reasonable measure about your future productivity. And also, they have a reasonable measure of how many bugs you introduce in this 25 lines of code. 0, 1, or 2, or 3, or 5. If 5, probably not going to pass. Right? If 0, nice work, move to the next stage. Right? So that's why having whiteboard test give you another dimension, which is basically first time mistakes. You see what I mean there? And so because you're not using a debugger, you're not using IDE, IDE is not auto-correcting for you. Basically, this is when you write code without any support first time, how many mistakes you make within the number of code, which is a very good indicator of proportionally how many mistakes you will make in a large chunk of code. Okay? So all these, what are these things? This is so-called metrics. Okay? I mean, just think about how Amazon and Google and Facebook using AI or machine learning to track everybody. They use the same metrics and same tools on you guys as software engineers to evaluate how effective you are too. Okay, so knowing what to expect is crucial, right? So just pretty much that's why we're doing this kind of exercise, essentially to make sure that you guys are ready and understand that's going to be your working style for years to come. Okay. All right. So let's talk about software engineering in theory. This is in theory. Basically, everything happens in a linear fashion. We only need to do requirement once. We only need to do design once. We only need to do implementation once, and we deliver. I mean, you guys already have about 2 years doing this. You know this never happened. Okay? Nobody, no engineer, no software engineer can actually do this linear approach in reality at all. Not just that you couldn't do it, not the best engineer could even do this. Okay, this is really just imaginary theory that the best we can get. Okay, we do things once and never come back to it. Okay, in reality it's much messier than this. But for other engineering disciplines, they are actually running quite close to this. If you think about it, the building next door that's being constructed, they don't go back to requirement that often. They don't go back to design that often. They don't go back to implementation often. Once the concrete is poured, it's poured, right? It's really hard to go back. And for us, I mean, once the code is code, go back and redo, easy, right? Different discipline, all right? Just realize that. So we make mistakes, and also the key thing is the moving target problem. You may say, oh, after so many years, 60 years doing software engineering research and computer science research, why are we still having difficulty with the software systems? To be honest, we don't have problems with 1960s, 70s software system anymore because those things we know how to solve long time ago. What we don't know how to solve is a system as complex as Facebook. We don't have a good idea of how to measure, how to quantify, how to make sure it's correct, make sure it's not biased, which is totally untrue. It's very biased, right? Actually, it's incredibly insecure and infringing on our privacy all the time. Okay, so essentially we are dealing with a moving target as well. I mean, 50 years ago, I mean, to code this guy, okay, this is actually a computer inside, right? This is actually a computer inside. To code this guy will probably take a team as big as you guys. Okay? Coding this right now take half of you a day. Okay? So we already know how to deal with things like this size. This is what we call IoT today, just different name, but it's actually nothing much different than just give these guys wireless connectivity. Okay? But we know how to program things like that. We know how to handle them. What we don't know how to handle is if we are going to automate this whole building and put internet connection on everything, including the elevator, including all the doors, including all the sprinklers and everything. Guess what? Somebody sitting probably in Russia is looking at this and laughing at, oh, great! I'm going to turn on the sprinkler and have you guys give you guys some artificial rain here, right? This actually could happen if you put connection on it, right? That is a problem we haven't solved. How could you reliably do a system like that and then you can place your 100% trust on that system? That's why, although there are so many hot news about autopilot cars, that would not come anytime soon, right? So essentially, actually, all the fancier new car with all these wireless connections are incredibly unreliable in terms of being hacked and being attacked. Okay, that is a problem we haven't solved. It's not like we haven't solved any problem, just that problem is getting bigger and bigger. Same thing that when you are in software engineering, you're very likely going to a situation when the client, they are not even clear about what they want to do. Okay? That is coming back to why we want to do incremental development agile processes. Because you don't even know whether your client will change their mind within 2 weeks. Okay? That's why you cannot commit to that yet. Then you want to deliver something and they will say, no, this is not what we want. Guess what? We lost 2 weeks worth of work. But we figure out what they need now. Right? Unlike we lock down that thing for 2 years and without talking to our client, I mean, you're going to make 100% mistake. Okay? So iteration, incremental things. So essentially, we just keep go back to the previous flow. We actually, hopefully, each successive version will moving more closer to our final product, and then eventually we'll deliver the thing. But you know, as you can see, even for Facebook itself, it's a moving target, right? The system is changing all the time, almost every day. New features, new things every day. So if Mark Zuckerberg actually say, okay, let's shut down Facebook for 5 years, let's redesign the whole thing, and we'll put something out there far better 5 years. You know what's going to happen, right? Facebook as a company already disappeared within the second year, right? They run out of money. Essentially, that is not going to work. That is why the only way for us to move forward is actually doing short iteration and the small increments. Okay? So now your engineering time are going to be measured basically in terms of hours, days, weeks, and 2 weeks. Anything longer than a month is very shaky. Very shaky. If you make a plan for 1 month of work without revisiting the work, it's going to be very shaky. That is a software engineering situation we have right now. All right? So essentially, also we cannot